Have you ever felt like your AI assistant just doesn't quite get you? Like, at all? Well, what if you could build one that actually thinks, writes, and even codes in your own unique style? Today, that's exactly what we're going to do. We're diving into the LLM Engineer's Handbook to figure out how to build our very own personalized AI, our digital twin. So, let's start with the big problem with the AI we all use every day. I mean, tools like ChatGPT and Gemini are incredible, right? But they've got one huge limitation. They're totally generic. They can't capture your voice, your way of thinking. Just think about it for a second. Doesn't the output from your AI assistant sometimes feel a little impersonal? Almost like it could have been written by literally anyone on the planet? That's the whole problem we're talking about. These models are designed to be general purpose, so they completely miss the little quirks and nuances that make your communication uniquely yours. And just look at the difference here. On the left, you've got that typical wordy, kind of bland, generic response. But on the right, that's an answer that sounds like it came straight from you. This is the whole promise of an LLM twin, taking your digital footprint and transforming it into an AI that truly gets you.
Okay, so how in the world do we actually build this thing? Well, it's definitely not as simple as just writing a quick script. To do this right, we need a really robust system, something that can connect dozens of super complex parts into one single, well-oiled machine.
And the whole thing relies on this discipline called MLOps, or machine learning operations. The best way to think about it is like air traffic control for our entire AI project. It's the set of rules and practices that make sure everything, from grabbing the data all the way to deploying the model, works together perfectly and reliably, without any crashes.
So what does this MLOps assembly line look like? Well, it's really broken down into three main pipelines. First up, you have the feature pipeline. This is where we gather all the raw materials, all of your digital data, and get it cleaned up. Next, the training pipeline takes all those clean parts and uses them to actually build the AI model. And then finally, the inference pipeline is what ships that finished product out into the real world so you can use it.
All right, let's start at the very beginning of that assembly line, forging the data. To create a personalized AI, we've got to gather the raw materials first. And in this case, that's your digital footprint. We're talking every post, every article, every message, every single line of code you've ever written. And this brings us to a fundamental, unbreakable rule of AI. Garbage in, garbage out. It's really that simple. The quality of your AI is 100% tied to the quality of your data. If you feed it messy, junk data, you're going to get a messy, junk AI that sounds nothing like you. There's just no way around it.
So how does this whole data forging thing actually work? Well, first, we slurp in all that raw text from your different digital sources. Then, we clean it all up, getting rid of anything that's irrelevant. After that, we break it all down into smaller, more manageable, bite-sized chunks. And finally, we transform those chunks into a special format the AI can actually learn from. Basically, a high-quality data set of instructions and answers.
Okay, so now we've got our super high-quality data ready to go. We're moving to the next station on the assembly line, the training pipeline. This is the fun part, where we use our brand new instruction data set to teach a base AI model how to think and write just like you.
Now, the traditional way to do this is something called full fine-tuning. And honestly, you can think of it like trying to teach someone a new language by making them relearn every single word they've ever known, from scratch. It works, for sure, but it is incredibly slow and unbelievably expensive. Yeah, not exactly practical for most of us. And this is where a much smarter approach comes into play. It's called parameter efficient fine-tuning, or PEFT for short. Instead of retraining that whole massive model, we just freeze its core knowledge. That's the big blue box here. And we add a small new layer of training right on top. It's kind of like learning a new skill without having to go all the way back to kindergarten. A really popular PEFT method is called LoRA, or low-rank adaptation. And this, right here, is the real breakthrough. Instead of rewriting the entire textbook, you're basically just adding a few little sticky notes with the new, important information. And those sticky notes are the only things that get trained, which saves a massive amount of time and computing power. It's what makes this kind of personalization actually possible for everyone. So we have our trained model. It thinks like us. Awesome. Now we've reached the final challenge on the assembly line. We have to make it fast enough and small enough to actually be useful in the real world. This is where optimization comes in.
And a key technique for this is called quantization. It's a bit like taking a super high-resolution photo and saving it as a JPEG. Sure, you might lose a tiny imperceptible bit of detail, but the file size becomes so much smaller and way easier to work with.
For our AI, this makes the model smaller and a whole lot faster.
So, how does this compression magic actually work? Well, quantization takes a huge range of really complex numbers and basically squeezes them into a much smaller, more manageable set. It's like taking a really long, complicated sentence and summarizing it in just a few key words. That simplification is exactly what makes the model so much more efficient.
And the results? They're pretty stunning. With something called 4-bit quantization, you can shrink a model by up to 4 times. I mean, that's the difference between an AI that can run on your laptop and one that needs an entire data center all to itself. It's a huge deal.
And there you have it. That is the complete assembly line for building your very own digital twin. We've gone all the way from a generic one-size-fits-all chatbot to a truly personalized AI companion, and we built it all on a solid MLOps foundation.
I mean, just take a second to let that sink in. We've taken all these scattered pieces of your digital life, every post, every article, every little code snippet, and we've forged them into an AI that actually captures your voice. It's just an incredible feat of engineering when you think about it. And you know, that brings us to a really fascinating thought. This kind of technology, it's not science fiction anymore. It's becoming a reality right now. So, I'll leave you with this question. If you could build your very own digital twin, what would be the first thing you'd ask it to do?